All right, in this video, we're going to be talking about isosceles and equilateral triangles. Just to let you know, I am recording this video at home. You may hear dogs barking. There are no dogs in the classroom. There are no dogs in the school. This is at my house. All right, so an isosceles triangle is a triangle that has at least two congruent sides. The two congruent sides are called the legs. So here, AB and AC would be the legs. Where the legs meet this bottom, the bottom is called the base. And where the legs meet the base, you have what are called base angles. The angle that is not the base angle is called the vertex angle. Okay? Most of the time, I'll try to draw the triangle looking like this, but you might see an isosceles triangle like this. So don't always think the base has to be the bottom. What I like to do is use these little tick marks that say these sides are the same, and I think of them as arrows that point to the congruent angles. The angle that's not the same up here is called the vertex angle. So it doesn't need to be on the top. Most of the time, though, you'll like it in that orientation. All right, so we have two new theorems. We have the first one that says that if these sides are the same, then these angles are the same. So if this is 4 and this is 4, and then I say this angle is 80, I'm just making that up, then automatically this angle right here is going to be 80. Technically, what's happening is you have these congruent. If I drop down a perpendicular bisector, you can prove the two triangles were congruent by HL. You could also say it's reflexive here. So it's side, 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 angle, side. Either way, all you need to know is that these two are the same. Okay, so we're going to call this ITT1. ITT1 stands for isosceles triangle theorem number 1. If AB is congruent to AC, then angle B is congruent to angle C. And if that's ITT1, then the converse of that, if I switch it, says that if these angles are the same, then these legs are the same. And we're going to call that ITT2. A few years ago, somebody came up with an easy way to remember ITT1 versus ITT2. ITT1, the 1 looks like a tick mark. So if you see tick marks, that allows you, what is that word I wrote? Marks. That allows you to say that angles are congruent. And ITT2, the 2 looks like it's part of an angle. So if two angles are the same, then the two sides are the same, the two legs are the same. So in this case, if B is congruent to C, then AB is congruent to AC. Easy enough. So here's the first one. Again, this should really just be a review, but we now officially have names for these theorems. So I have two legs that are the same. That's ITT1. I'm going to set the base angles equal to each other. This becomes 2x is 14, x equals 7. Go ahead and try these. (180 minus 78 leaves you with 102, and then you need to separate the 102 between the two congruent angles, so you wind up with 51. Here are your two legs. They point to these angles. 180 minus 86 is 94, divided by 2 is 47, so these are both 47. These two angles are congruent. 6x, I believe. Let's make it a 16. I don't know, it could be an 18. Let's just make it a 16. It won't matter. If I do this, I get 16 equals 2x, and then I get x equals 8. Be careful because this wants you to get the measure of the angle. So h is 8 x's. which means that 8 eighths, because I have 8 down here, would be 64. And then for the last one, 2x equals x plus 30. Move the x over. You get x equals 30. If x equals 30, then this angle right here equals 60. This angle right here also equals 60. However, this triangle is very special because it's not just an isosceles triangle. If this is 60 and this 60, you should be able to recognize automatically that this top base vertex angle is also 60. So yeah, it's isosceles, but it's more specifically an equilateral triangle. So those are the notes on isosceles triangles. I guess my dogs are sleeping because nobody barked. And you're going to do the worksheet on the Go Formative. If you have questions, let me know. Work with somebody. And you should be able to check the answers on the Go Formative.